Welcome back. This is Mr. Hassan's Maths channel, and I'm going to now answer questions from the June 2023 International A-Level Edexcel Pure Mathematics P3 paper. And I'm going to go through the questions in this paper one by one, separate video for each question, in order that I can save the videos by playlist, as well as a playlist to do with the paper, as well as to do with the topic it's from. And I'm going to be going through this paper, trying to explain in some detail, in some cases, some of the questions, so that people who maybe need to understand topics a bit more deeply, or they weren't taught properly, or they are homeschooled or whatever, that they can benefit from the video. So don't expect this just to be a talking mark scheme. I might take a bit of time answering questions to go through and explain things in a bit more detail. So if you're looking for a talking mark scheme, then this maybe is not the right place for you. Okay, so bear that in mind. So let's start. The first question here in this paper is a question that's given us a function g of x equals x to the power of 6 plus 2x minus 1000. And part A of the question says, show that g of x equals 0 has a root alpha in the interval 3, 4. Okay, so the root of this equation, gx equals 0, is basically the solution to this equation, the values of x that cause this equation to equal 0. So we have to try to show that there is a root somewhere between 3 and 4. Now, some people will be confused by looking at something like this. They might not be used to seeing this notation. This actually is not like the coordinates of a point. Okay, what this is an interval. It's like an inequality. It means the values between 3 and 4. Sorry about that. 1 second. Let me sort that out. The values between 3 and 4. Okay, so actually this can be rewritten like this. That the value of alpha, we can say alpha is somewhere between 3 and 4. Okay, the value of alpha is somewhere between 3 and 4. Okay, that's what it means. So we got to prove that the value of alpha is somewhere between 3 and 4. So how do we do this? Okay, so what we do is, first of all, what we can see is this is what's called a continuous function. Okay, it's something which doesn't have any asymptotes. So it continues. It can take all values of x. And if we were to sketch this function, there will be some point, obviously, where it passes through gx equals 0, maybe more than one point, probably more than one, right? But one of the points at which it passes through y equals 0, when gx is equal to 0, that's basically the x-axis, okay, is going to be somewhere between 3 and 4. So let's say this is our axis. Let's say this is x equals 3 and this x equals 4. Somewhere between these two, it passes through the x-axis. Okay, let's say that's the point, somewhere between these two. We've got to prove that it does pass somewhere between 3 and 4. So what we do is we take the function and we replace the x with 3 first. So we're going to put 3, which gives us 3 to the power of 6 plus 2 times 3 minus 1000. Okay, so that's going to give us 3 to the power of 6 minus 2 times 3 plus 2 times 3, not bad. And then, 1 second, plus 2 times 3, and then minus 1000. Minus 1000. Now that gives us a value of negative 265. Negative 265. So that's basically the y value at this point. That's the y value at this point, negative 265. Okay, so the coordinates of this point are basically 3 and negative 265. That's the coordinates of this point. And then when we put x equals 4 into the equation, so we find what g4 is, we're going to have 4 to the power of 6 plus 2 times 4 minus 1000. And we see what that gives us. We can just go back and replace that 3 here with a 4. And replace that 3 here also with a 4. Now what does that give us? That gives us 3104. 3,104. So that means when x equals 4, then the coordinates of that point is 3,104. It's now above the x-axis. So when x equals 3, the function has a value below the x-axis. When x equals 4, it has a value somewhere above the x-axis. That means somewhere between these two values, 3 and 4, the curve must have passed through the x-axis. So the root alpha must be somewhere between 3 and 4. So what we can say as a statement after this, as g of x is a continuous function. Continuous function meaning it doesn't have asymptotes or anything like that. There's no break in it. Okay, like for example, if there was an asymptote, it's possible to have an asymptote and to be below the x-axis at 3 and above it at 4, but there's an asymptote. There's no root here, but it does go above the x-axis between these values. It does change. But because this is not a type of function that has an asymptote, it's a continuous function. As g of x is a continuous function, and there is, try to be as neat as possible, there is a change of sign between g3 and g4. Therefore, the root, which is alpha, must, or a root, because there could be other roots, a root alpha must lie in, my God, sorry about my handwriting, must lie in the interval 3, 4. Okay, which can be written as this way if you want. Okay, so there is the answer to part A of this question. Okay, so I hope a lot of people know that, you put 3 in here, you put 4 in here, and if there's a change in sign, that means their root lies, but they might not understand the reason behind it. And that's the reason behind it, because a curve somewhere between 3 and 4 must have passed through the x-axis for the root to be there. Okay, so that's part A. Now for part B, it says use the iteration formula xn plus 1 equals the square root of, the sixth root of 1,000 minus 2xn with x1 equals 3. We've got to find to 4 decimal places the value of x2. Okay, so basically this is a formula where you have, but what they've done is they've rearranged this equation here and they've made this x the subject. So they added 1,000 and took away 2x from both sides. So they ended up with this equation, because the original equation is g of x equals x to the power of 6 plus, what was it, 2x minus 1,000. Okay, so they've obviously made this x the subject. So they added 1,000, subtracted 2x, and took the sixth root of both sides. So they end up with what is called, this is the iteration formula. This helps you to home into the root as long as you choose a value of x to begin with, which is close to the root. Okay, so we know the root somewhere between 3 and 4. So what they've told us to do is to use the first value of x as 3 and put it into this iteration formula. So we're going to take x1 as 3, and we're going to replace the x here with 3. So we have x2 will therefore be the sixth root of 1,000 minus 2 times 3. Okay, now what I'm going to do is I'm going to set it up in my calculator so I can answer the other questions easily, because part 2 you have to keep on putting back the value in until you get the numbers settled to a particular root. So what we're going to do is we're going to put, we have to start off with 3, so I'm going to put 3 and press equals. That's like our x1. That's like the first value of x we're putting in. All right, now what I'm going to do is, so this is like the answer in my calculator. Now whenever I press the answer button and press equals, that will be 3. Okay, so what I'm going to do is I'm going to set up this little expression here and put it in the calculator. So I'll have the sixth root, so I'm going to start off with this button over here. So I have this button here, I'll put the sixth root of, and inside here I'll have 1,000 minus 2 times answer. Okay, why answer? Because that is the 3 that I put in once I pressed equals in the beginning. So what this is going to do, it's going to, when I press equals, it's going to give me, okay, this value with the 3 in place of where the answer is. because 3 is my last answer in the calculator, because I press 3 in equals. So now when I press equals, that's going to give me what x2 is, which is 3.15917. Let me just check that. 159107. Okay, now it says to 4 decimal places. To 4 decimal places. So to 4 decimal places, that's 3.1591. Okay, that's the answer to 4 decimal places. Sorry, 4 decimal places. All right, that's part 1. Now for part 2, it tells us find by repeated iteration the value of alpha. So basically, we've got to find what x3 is, what x4 is, what x5 is, and all we have to do now, because we set up in the calculator, we have to write all this out again. I have to press equals, because what does x3 mean? It means put the value of x3. If you look at this, x3 would be all of this, the 6 root of 1000 minus 2 times x2. So I've got to take x2 and put it into this formula. Okay, that's what I have to do. So if you notice, this is now my new answer. So when I press equals again, it's going to put this answer in that place. So it's going to put x2 into this formula, and that will give us x3. So I press this, you'll see it becomes 3.15893. Okay, so 3.15898. 3.1589388 goes on like that. Okay, I don't actually have to write this all down. I'm just doing it for the sake of showing you guys. Then when I press equals again, it's going to put this value back into there. So it's very easy. I have to keep typing out again. So press equals again. You have 3.158939. 3.158939. 3.158939. As you can see, it's starting to settle down. Okay, it's going to end up being just one number in the end. It will settle down to one number. Press equals again. You can see now the only number change that there is at the end. So this is also 3.158939. So we can see very clearly that we have got to our number. If we want to round it to 4 decimal places, 1, 2, 3, 4, that's our answer. So we can say, therefore, alpha, which is the root, is 3.1589, correct to 4 decimal places. That's the root, correct to 4 decimal places. Okay, the decimal places continue, can carry on, but they want it up to 4 decimal places. Now we can see this has settled down up to that 4 decimal places. If I keep pressing equals, it won't actually change because the changes might be further down. So that is the root, correct to 4 decimal places. Okay, so there's the answer to part B, part 2. And that concludes this question. Now, very common in this question is for them to ask you or to ask you to do something else, which is not asked in this question, right? It's not asked in this question, but just for the sake of your revision, if it comes to another exam, they might ask you this other part. Another paper, they might ask you this other part. So I'm going to explain how you would, and I'm going to make up my own question 3. Okay, justify. They might ask you to justify that alpha equals 3.1589. Okay, to 4 decimal places. All right, you want to justify that that's the root to 4 decimal places. So what we do is we take this number, okay, and we think about if it rounded to 4 decimal places to become this, think about what the highest it could have been before you rounded it and what the lowest it could have been before you rounded it. Okay, what's the highest number it could have been before you rounded it, and what's the lowest number before it rounded to 4 decimal places? So it's more than 4 decimal places, and you rounded it to 4 decimal places, like, for example, what we did here. Now, if you think about it, if this number here is 5, so if this was 3.15895, that's the highest you can go without actually getting that number. So anything just below that, you can reach, and it will round to this value. So not including this number, but something just below this number. Okay. And even for example, 3.1589499, that will round to 3.1589. Okay. So this is 3.1589. 3.1589 to 4 decimal places. Now, what's the lowest it can go before you round it up such that it will become 3.1589? Well, that's if it was 3.1588. 8, that has to be 19, so 85, yes. 3.15885. Okay, if you round this to 4 decimal places, it's going to become 3.1589. Okay, so basically you take this and you add a 5 at the end and you take away a 5 from this last thing here. So you have, and that will become 95 and 85. Okay, so 95 and 85. Okay, so here you have 3.15885. If you round that to 4 decimal places, what will become? 3.1589. Okay, so it will become this number. Okay, and if you go any lower than that, it's going to round to 3.1588. It will be over here. So if we know that the root lies somewhere between these two values, including this one, but not quite including that one, anywhere between these two values, then any number that lies between here and here will round to this number when you round it to 4 decimal places. If the number's on this side, it's going to round to the number over there, or this, yeah, and so on. Okay, so basically, this to 4 decimal places, okay, any number that lies between these two values will round to 3.1589 to 4 decimal places. So to justify that 3.1589 is a root correct to 4 decimal places, we take our function, the original function, and we replace 3.15885 in it. And we also replace 3.15895 in it. And we see that there should be a change of sign. So we go back to the original equation that we had up here. Okay, so I can go back to the calculator here. I can go back to where we were. Can I go back to where we were? No, I pressed. No, so let's do it again. So we have, so we'll start with 3.15 to the power of 6 plus 2 times 3.15885. Okay. And then minus 1000. Now that gives us a value minus 0.168. Minus 0.168. And if we take the next value and put it in, okay, it's going to be exactly the same number, except at the end it's going to have a 95 instead of an 85. So I'll change that to 95. 15895. 15895. Yep. And this is also going to be 15895. When I press equals, you see it's positive now. So 0.0206, 0.021, you could say. So we can see that from here, between this value and that value, there's a change in sign. So the root passed somewhere between these two. So wherever it passed between these two, okay, wherever that value is, when you round it, it will round to this, to the nearest to 4 decimal places. Okay, but this part was not actually a question. All right, this is something which I invented because sometimes they do ask you to justify, but this was a question. Sorry. Okay, this part was not part of the actual question. I invented this part here in this question. I added it to just give you an idea of how to deal with questions when they do ask you to justify that your answer is actually a root correct to those number decimal places. You find the upper bound and you find the lower bound of that value. So basically you add a 5 at the end of the number. All right, so it'll be 895, and then it's like you kind of make this 90 and you add 5 to it and you take away 5 to it. That'll become 895 and 85. You substitute those values back into the original equation and you show that there's a change in sign between those values, which proves that the root must lie somewhere between these two, and any number that's bigger than this, less than that, will definitely round to this, to 4 decimal places. So that's how you deal with such questions. So that concludes question number 1 and a bit extra. Other questions from this particular paper can be found in the playlist that will appear in this region over here. Other questions from the topic of number iterations, and this particular topic here about iteration and numerical methods can be found in the playlist over here. You can subscribe to my channel by clicking on this link, and if you watch the video which links over here, you can find out how to use my channel to find what you need efficiently. Thank you for watching, and see you soon.